Okay, hello everyone. I'm Dhruv. I'm a research engineer at Stacker Labs, and my teammate Archit with me. During the past 2 days, during the weekend, we built Vulcan fast finality layer. It's a fast finality layer to bring fast transition finalities across Ethereum layer 2 rollups. So let's look at what it is. Uh, Here we execute all the transactions in a block to pessimistically verify the state change of the rollup. So for now, it is catered for the stacker's macro rollup specification, but it can be extended to other rollup standards as well. First of all, why we built it? I mean, rollup face significant challenges of absence and instant secure finality. Even Ethereum NL1, it takes 12 seconds to finalize a block. And to solve these problems, we implemented a fast finality layer, which takes the block containing transactions from the rollup, re-executes everything, the state transition functions, and validates the state change. So a rollup can assert a state change claim on the Vulcan layer, and if a majority of nodes attest to its validity, rollup clients can achieve economic finality almost instantaneously. So you get faster speeds and better transition executions. Now, this is what we already have. So to give you more context on what Stacker is a framework to build micro rollups. Imagine app chains, but in your own environment, in small environments, in your own language of your choice. So as a developer, you would define a state machine which contains the transition function, which will take the state from chain state A to state B. And then there is, after the action is being submitted, blocks are created as any other rollups, and then they are submitted after being executed locally. Now, Vulcan is the layer which verifies them and does the job of re-execution. In our case, currently it's a single node run by our team, but we want to put it on AVS to attain and use shared security. So, and at the end, everything is posted on chain, so the state root on L1 in the rollup contract and the data on DA. So yeah, now this is what we built during the hackathon. So we have a similar environment, which is the MRU environment, and after the block is being created, we have the service called Syncer service. The responsibility of the service is to simply take the blocks and, first of all, create the proof of task, sign them, and send them to IPFS as a proof of task. Then later, make an RPC call and send it to the authentic client for further verification. So in this case, there is no Vulcan, but this is what we built. We built a Vulcan version with AVS using the authentic stack. Now here, the tester entities can pick up these blocks. They can call the validate endpoint, which is what we hosted on our server, and it contains the logic for pessimistically verifying the execution of block again. So basically, in the back end, it will get the data. It will get the proof data from DA layer first of all, then prepare the block information, and then here is the interesting part of verification. So we have something called as WASM files. WASM files are nothing but they contain the logic of the state transition function. So whatever functions you defined earlier, like how you define functions in contracts, it's the logic, but in a WASM binary. And then we pass the inputs, the earlier state, and apply each and every transactions inside the block to this using this WASM file. And at the end, we get a new state root. Then we check if this new state root is exactly what the block proposed. So if it's same, then you can say the block is valid and it is verified. And then after this, the authentic stacks takes up everything else. So basically aggregating signatures from the testers using the BLS scheme and then posting them on chain in the attestation center contract later. So yeah, that's the major tech part of things. Now let's see a quick demo of how we can use this. So this is an interface which we already have to interact with our token transfer rollup. It's basically a token, like ERC into token, but on and rollup itself. So I'm going to burn some token from my account, and I've already added all the inputs, so we can just simply hit execute. There is signature right now, so there is no transaction, but signature, and we can see the action was submitted. So like my transaction is done. Now if we go over here, which is our rollup, so we can see here that there was a task being executed and a block was created. And then we can see the proof of task was published to IPFS, and then there was an API call to the RPC client. And if we go over to that section, which contains the testers and aggregators, we can see here that all the testers call the web API endpoint to get their task validated. And it starts with basically fetching the data from the DA layer, then going ahead and applying all the actions on top of it. And finally, it like executes them on the wasm file here. And at the end, we get a verification result. It was true in this case, so we can say the block was valid. And at the after everything, the task aggregator can pick it up, and because it was a majority, the block was executed and posted on chain in the center contract. So yeah, that's all on the demo. We are thinking of like building ahead and adding a full-fledged roll-up logic later after this. But yeah, that's all. Thank you for your time, and we had a great time building here.